This lesson is on using the side-angle-side congruence theorem. First thing we're going to do is just define it. The side-angle-side or SAS congruence theorem says that if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. And you can see a diagram down here. The first thing I want to point out is this idea of an included angle. So whenever they're talking about an included angle, they're talking about this angle right here. And what makes it included is that it is connected to the two sides that are marked. So angle A is the included angle with respect to side BA and side CA. And then we could say that angle B is the included angle with respect to side BC and side BA. And you could say that angle C is the included angle with respect to side BC and AC. So the included angle is just, touching or formed by those two sides there. So this is the included angle in this triangle, and angle D is the included angle with respect to ED and DF. So that's our included angle, and I'll circle this one as well. So it says if two sides and the included angle. So when they're talking about the two sides, they are, of course, talking about side AB and side AC in this triangle, side ED and side DF in this triangle. So obviously, based on these markings, AB is congruent to ED, DF is congruent to AC, and we have angle A is congruent to angle D. So we have everything we need for side-angle-side congruence theorem. Now, next thing I want to do is just go through an example problem of writing a proof involving this stuff. So we have given B is the midpoint of segment AD, angle ABC and angle DBC are right angles. We want to prove that triangle ABC is congruent to triangle DBC. So first thing I'm going to do here is just set up my two-column proof. And see if I can get a second line here. There we go. Okay, so obviously step one here, write my givens. So I know that B is the midpoint of AD. And that is given to us. So we know that this point B is the midpoint of segment AD. And our second given is that angle ABC and angle DBC are right angles. And that is also given to us. And we can see these are marked right here. So this is angle ABC and angle DBC is right here. Okay, so we're going to try to prove that these two triangles are congruent. And as you could probably guess, this is going to involve the side-angle-side congruence theorem. So what we're going for here would be a pair of congruent sides, a pair of congruent angles, and a pair of congruent sides. And we need to make sure that our pair of congruent angles are the included angles. Remember from the past when we talked about just some tips and tricks for getting through proofs, and one of the tips that we talked about was dealing with those keywords. So if we know that B is the midpoint of segment AD, this is a key word right here that we know the definition of. A midpoint divides a segment into two congruent segments. So if B is the midpoint, then in terms of congruency, we know that segment AB is congruent to segment BD. So we're going to write that step right here. So that's pulling directly from our given that B is the midpoint. So segment AB is congruent to segment BD. How did we know that? Well, that's what it means to be a midpoint. So we're just going to say definition of midpoint. Okay, so that gives us one pair of congruent sides. So we're basically 1/3 of the way there. I'm just going to put a little S here for the congruent sides. Next thing we know, if angle ABC and angle DBC are both right angles, well, we know if they're both right angles, hey, these are both 90 degrees. They are congruent to each other. So we are going to be able to say that angle ABC is congruent to angle DBC. How do we know that that's true? Well, that's using one of our theorems. That is the right angles congruence theorem. And if you don't remember the name of the theorem, you could, of course, just put here that all right angles are congruent. Okay, so that's a pair of congruent angles. Now we're 2/3 of the way there. So we need, remember, pair of congruent sides, a pair of congruent angles, and a pair of congruent sides. And notice that in this picture, we have this segment right here that is shared between triangle ABC and triangle DBC. So that's going to be our reflexive property. So we're going to be able to make the statement that segment BC is congruent to segment BC. And the reason is that's our reflexive property of congruence. And remember, things that you're looking for from the picture. Maybe you'll have a pair of vertical angles. Maybe you'll have the linear pair postulate coming up, or maybe you'll have the reflexive property coming up, where you have a triangle that is, sharing a side, like in this case. So notice that we have everything, and that's a pair of congruent sides right here. So notice we have everything we need. We have a pair of congruent sides, AB and BD, a pair of congruent angles with angle ABC and angle DBC, and our last pair of congruent sides with BC congruent to itself. And notice that our angle is the included angle. This angle ABC is included with respect to our two marked sides, and same thing on this side with this triangle. Angle DBC is the included angle with respect to our two marked sides. So we're ready to finish off this proof, and we can just state that triangle ABC is congruent to triangle DBC, and this is by the side angle side congruence theorem.